Anaximander of Miletus, circa 611 to circa 546 BC. A work of metaphysics first transcribed 6th century BC. The principal ideas are that the universe arose out of an indefinite boundless, a mass of undifferentiated material. The basic material of the universe was none of the elements, earth, air, fire, water, but something intermediate. The world was generated when the hot and the cold were separated from the boundless by its eternal motion. The earth is shaped like a drum and is surrounded by fire-filled hoops of mist, with holes on their inner sides, the sun, moon, and stars. Justice is achieved in nature by the process of a return of all things to their origins. Thales of Miletus is traditionally credited with having been the first philosopher, since he was the first to put forward a non-mythological account of the origin and nature of things, but we know no more of his views than that he claimed that all things originated from water, and it is unlikely that he worked out this thesis in detail. It remains for his pupil and successor Anaximander to produce the first comprehensive natural philosophy, a system of astonishing acumen and sophistication. Anaximander conceived his problem to be that of explaining how the present constitution of the universe developed out of a primordial condition of simplicity. Apparently he did not consider the possibility that things had always been much the same. To this extent he inherited the notion of evolution from Near Eastern mythologies, which all told of how the world had been fashioned out of a pre-existing chaos or homogeneous matter, usually water. But in rejecting divine personal agency and in substituting a more or less continuous process for separate acts of creation, Anaximander radically transformed the idea. Anaximander postulated an undifferentiated stuff out of which the world arose. He called it the boundless. This was not any one of the traditional elements, earth, air, or rather at that date mist, fire and water, but something intermediate. Since it was no more wet than dry and no more hot than cold, it was presumably damp and tepid. In opposition to Thales, who held that the basic stuff to be water, Anaximander conceived it as the neutral, on the ground that the elements are in opposition to one another. Air is cold, water is moist, fire hot, and therefore if any one of them were infinite, the rest would have ceased to be by this time. This is the first recorded philosophical argument, a criticism of a predecessor's view supported by an appeal to reason rather than to revelation or to a special mode of insight. The boundless was supposed to be infinite in extent and ageless and deathless, that is, infinite in time. Anaximander, it seems, called it divine, but only because of its agelessness and deathlessness. He did not attribute to it any characteristics of personality or, as far as we know, intelligent consciousness. The boundless was also said to encompass all the worlds, implying an infinite or at least indefinitely large number of individual worlds like this one. The initial step in the generation of a world occurs when, as a result of eternal motion, we are not told how, something capable of begetting hot and cold out of the eternal is separated off. The hot and the cold, conceived as things, not as qualities of a substance, separate, and at the same time a motion in rotation is imparted to them. The hot, which is fire, encircles like a bark around a tree. The cold, which contains earth, mist, and water. In due course these latter three also separate, the earth remaining at the centre of the whirl, with the water in a ring around it, which is in turn enclosed in a circle of mist. The fire around the mist and water heats them until pressure builds up, which, combined with the centrifugal force of the whirl, results in a cosmic explosion. The mist is caused to shut up the fire in gigantic hoops, like inner tubes, which circle around the earth. The earth is shaped like a drum, the diameter being 3 times as great as the depth. We live on one of the flat surfaces. Though supported by nothing, The Earth remains at the centre because of its equal distance from everything. The surface of the Earth, which was at first entirely submerged, is now partly dry, and it keeps getting drier through continued evaporation. The sea is what is left of the original moisture. The fire has dried up most of it and turned the rest salt by scorching it. Fire-filled hoops of mist at distances of 18 and 27 Earth radii surround the Earth and revolve around it. Each of these hoops has on its inner side one hole, like the nozzle of a bellows, or, in a more modern figure, like the valve hole of an inner tube, through which the fire shines. The hoop 18 Earth radii out is the hoop 18 Earth radii out is the moon. The outermost is the sun. The diameter of the sun, that is, of the opening in the sun hoop, is as great as that of the Earth. Eclipses and the moon's phases are explained as obstructions over the holes. We are not told what closes them. The stars are the innermost hoops, presumably 9 Earth radii out from us. Anaximander would understandably infer that they were the hoops nearest us, for otherwise the hoops of sun and moon ought to appear as black bands in the night sky, but these thin, faint star hoops would not interfere with the greater lights of the sun and the moon. Even if Anaximander did not affirm the rotation of the Earth, his model of the world contains two very important new ideas. One is that of an Earth without material support. An earlier, and indeed many later, cosmologists thought themselves obliged to explain this Earth's fixity by providing supports. Anaximander, seeing that such shifts only moved the problem back a step or two without sort of solving it, declared boldly that the Earth stays at the centre because of its equal distance from everything. The other new idea is that of explanation in terms of a theory involving postulated entities, for we certainly do not see the hoops, we see only the breathing holes. Why did Anaximander postulate the hoops, instead of resting content with a simpler common-sense conception of fiery spheres or disks? Our ancient sources give no hint, however. Only one answer seems possible. Anaximander must have reasoned this way. Heavy bodies near the Earth tend to move towards the centre of concentration of mass, that is, towards the centre of the Earth. Now the Earth, being a very heavy body, should likewise move toward the greater concentration of mass, if there is one. And there appear to be at least two, the sun and the moon. Therefore, if the sun and moon are what they appear to be, the Earth ought to move toward the sun, toward them, or they toward us. Since this does not happen, the Earth must really be equidistant from these bodies, despite appearances. This condition could only hold if the bodies surround the Earth symmetrically, that is, are hoops, of which only the breathing holes are visible. The idea of mist wrapping up fire, which seems strange to us, was natural enough to Anaximander, since lightning emerging from clouds easily suggests such a notion. We know that, in fact, Anaximander explained lightning in some such way. When the wind is shut up in a cloud and bursts forth violently, the tearing of the cloud makes the noise of thunder, and the rift gives the appearance of a flash. If this conjectural restoration of Anaximander's reasoning is correct, then Anaximander grasped the essential nature of theoretical explanation, of a law or natural regularity holding universally, in this instance gravitation, and accounting for or generalized from observation, falling bodies on the Earth's surface, leading to the hypothesis of unobserved entities, the hoops, in order to render the other observed phenomena, the sun, the moon, and not falling, consistent with the law. This is 9/10 of scientific method as now understood. Had he devised or admitted the necessity of some test of the hoop hypothesis, he would have had the other 10th. And even if he did not reason in this way, it seems that the hoops must have played this role of hypothetical entities, in respect to some general theory. for there was no traditional or mythological incentive for supporting them. In consequence, the scientific nature of Anaximander's thought is established. The power and originality of Anaximander's thought is displayed Sorry, a big mistake there. The power and originality, I have trouble reading my notes sometimes. The power and originality of Anaximander's thought is displayed preeminently in his biology. Myth-making, even when it is assumed a development of the cosmos as a whole, always conceived of animals, including man, as having appeared on the scene from nowhere in their latter-day form, either as special creations of the gods or in some unexplained manner. In sharp contrast to this sort of facile storytelling, Anaximander worked out a theory of animal evolution based on the ideas of adaptation to the environment and survival of the fittest. His starting point was the observation that while other animals quickly find food by themselves, man alone requires a lengthy period of suckling. Yes, then you have to wait 18 years before you get that close to them again. Anyway. Hence, had he been originally as he is now, he would never have survived. That is to say, perhaps I should go through that again without a joke. While other animals quickly find food by themselves, man alone requires a lengthy period of suckling. Hence, had he been originally as he is now, he would never have survived. That is to say, a theory of the world which in general is evolutionary is incompatible with the human species having appeared all at once as babies, for if it had, it could never have survived in the state of nature. It follows that animals whose young are long immature must be the products of gradual development, presumably including socialization, from some other kind of life not so ill-fitted for the world. Furthermore, the theory that in the beginning there had been no dry land suggested, if it did not require, that all life originated in the sea. Hence living creatures arose from the moist element as it was evaporated by the sun. The transition from marine to terrestrial life occurred thus. The first animals were produced in the moisture, each enclosed in a prickly bark. As they advanced in age, they came out upon the drier part. When the bark broke off, they survived for a short time. As for human beings in particular, they too were like other animals, namely fish, in the beginning. At first, human beings arose in the inside of fishes, and after having been reared like sharks and become capable of protecting themselves, they were finally cast ashore and took to land. The mention of sharks was not fanciful, but based on the acute observation, to be sure quite possibly made by somebody else, that certain sharks of the eastern Mediterranean hatch their eggs inside their bodies so that they seem akin to mammals. Anaximander wrote a book, the Western world's first scientific treatise, of which one sentence or part of a sentence has been preserved. Things return to their origin, as is ordained, for they give satisfaction and reparation to one another for their injustice, according to the ordering of time. It is clear from this that Anaximander's philosophy made use of the concept of justice, pervasive of Greek thought, according to which there is an impersonal and inexorable force in nature charged with keeping things balanced in society and in the world at large. Every person, state, and element has its allotted portion, and injustice, the encroachment of anything beyond its bounds, is followed automatically and surely by restorative retribution. The notion lies at the root of both Greek moral ideas and the conception of laws of nature. In the fragment of Anaximander, we find it evidently being developed to the direction of the latter. It would be risky to infer anything more as to Anaximander's worldview from this half-sentence. In particular, it by no means shows that Anaximander viewed the universe as inherently moral, in any sense that we would naturally give to that expression, even allowing for the fact that in Greek and other Near Eastern thought, before the 6th century BC, there existed a discernible tendency toward rationalization of traditional myths, and that of the myths themselves contained the kernels of evolutionary and natural law concepts. It is hardly an exaggeration to say that Anaximander single-handedly invented science and philosophy as we know them. Above all, he put rationalism on such a firm foundation that among the educated it took mythology 1,000 years to overthrow it. And even then it did not perish utterly. Any naturalistic worldview at the beginning of the 6th century would be remarkable. It is staggering to find that the very first philosophy contained such transcendently important ideas as the unsupported earth, theoretical explanation involving inferred entities, and animal evolution from marine organisms to man in accordance with a principle of adaptation, and quite possibly the earth's rotation and gravitation in addition. It is not surprising that Anaximander's immediate successor, Anaximenes, was incapable of such daring speculation. He accordingly taught a more common-sense philosophy in which the earth was held up by mist, the unobservable hoops were abolished, and the sun, moon, and stars were the fiery leaves floating in the air. He was, so to speak, the first positivist. The beliefs that the earth needed a support continued to be held in Anaximander's homeland for a century, down to and including Anaxagoras, whose philosophy was otherwise essentially an elaboration of Anaximander's. But the Pythagoreans adapted Anaximander's astronomy, hoops, and all at first, since, as is well known, Copernicus and Kepler were strongly influenced by Pythagorean theories. It is possible to demonstrate a continuous chain of development in this science from Miletus to Mount Palomar. Unfortunately, Anaximander's equally promising beginnings in biology bear no fruit. Though Empedocles also recognized the principle of adaptation, the details of his evolutionary theory were fantastic, and after his time the authority of Aristotle in favor of fixity of species put an end to evolutionary speculation in the ancient world. The revival 2,000 years later owed little, perhaps nothing, to Anaximander.